Today, we will discuss the first law of thermodynamics, which is essentially the law of conservation of energy applied to thermal systems. Let us start with a simple idea. Energy cannot be created and it cannot be destroyed. It can only be transformed from one form to another. The first law expresses this principle in terms of heat and work. In thermodynamics, we deal with a system, that is, a part of the universe under study, and its surroundings. When heat is supplied to a system, two things can happen. Part of that energy can be used to do work, and the remaining part can be stored in the system as internal energy. Mathematically, the first law is written as Q equals delta U plus W. Here, Q is the heat supplied to the system. Delta U represents the change in internal energy of the system, and W is the work done by the system on its surroundings. This equation tells us that the heat given to a system is partly used to increase its internal energy, and partly used to perform work. Let us understand this with an example. Consider a gas enclosed in a cylinder with a movable piston. When heat is supplied to the gas, its molecules move faster, increasing its internal energy. At the same time, the gas expands and pushes the piston outward, doing work on the surroundings. Now it is important to remember the sign convention. If heat is added to the system, Q is taken as positive. If the system does work on the surroundings, W is also taken as positive. Accordingly, the internal energy changes. In simple words, the first law of thermodynamics tells us how energy flows and transforms within a system. To conclude, this law connects heat, work, and internal energy and forms the backbone of energy analysis in physics. Thank you.